In this video, we will see what is Singleton Design Pattern, in how many ways we can create a Singleton Design Pattern or a Singleton class, and what is the best practice to create this Singleton Design class. So let's get started. So what is Singleton Design Pattern? Singleton Design Pattern is a creational design pattern and is basically used to create a single instance of the class so that single instance can be reused again and again. So now the question arises, where all we can use this Singleton Design Pattern. This Singleton Design Pattern can be used in many scenarios. So few scenarios are like while working with the databases, or while working with the logging, or while working with the caching. So here we can use this Singleton Design Pattern. So what are the advantages? Why should we use this Singleton Design Pattern? So with the help of this Singleton Design Pattern, we can save a hell lot of a memory because a single instance will be created and that will be reused again and again, and on each request a new object or a new instance will not be created, right? So that will save a hell lot of a memory. So now we will move on to the next question. What are the different approaches in which we can create the Singleton Design Pattern? So our first approach is eager singleton. So in this case, the instance will be created at the time of loading of the class. So now we will see how we can create this eager singleton class. So here I have created one class called eager singleton. I have created the private constructor of this eager singleton class. So here I have created the instance of this class, and this instance will be created at the time of loading of the class only. So here I have created one method called getInstance, which is the global point of access to this particular class, and this method returns the instance which we have created here, right? So now I have created one more class called test.java. So in this class we will just create the object of this class and we will print the hash code. So here I have created two objects of this eager singleton class, and I'm trying to print the hash code of these two objects. So here if you could see, these two objects are returning the same hash code. That means this eager singleton class is following the I will not recommend this eager singleton to be used, because in this case the instance is created at the time of loading of the class only. Irrespective we need the instance or not, the instance will be created, right? So it will lead to some performance issue. So now we will move to the next approach. So our next approach is lazy singleton. So in case of this lazy singleton, the instance will be created whenever it will be needed, not at the time of loading of the class. So now we will create a class. So here we have created a class called lazy singleton. So in this class we have created a constructor, private constructor. So here we have created the instance of this class. So here I have created the method called getInstance, which is the global point of access for this particular class. So here inside this method we are first checking if instance is equal to null, then only create the object and return, else we will just return the instance which is been created previously. Okay, so now we will move to this test.java and we will check this lazy singleton. So here also we have created the two objects of this lazy singleton class, and we are trying to print the hash code of these two objects. So here if you could see, these two objects are also returning the same hash code. That means this lazy singleton class is also following the singleton behavior. So but this lazy singleton is better approach as compared to eager singleton, but not the best approach, because we cannot use it in the multi-threaded environment. Because if we will use this in the multi-threaded environment, then two or more than two threads can come and will create the more than one object, right? So that will break our singleton behavior. So to avoid this, we are going to use one more approach. That approach is called double checking lazy singleton. So for that we will create one more class called double checking lazy singleton. So we have created this class called double checking lazy singleton. Now we will create the private constructor of this class. So here is the private constructor of this class. So here also we have created the instance. Now we will create the method called getInstance, which will be the global point of access to this particular class. So here we have created the method called getInstance, which is the global point of access to this particular class. So in this, now we will create the instance. So here we are checking if instance is equal to null, then we will to avoid the race condition, we will use the synchronized keyword. We are going to use the synchronized block here. So to avoid the race condition, we have used here synchronized block, and inside this again we are checking. So to avoid the race condition, we have used this synchronized block, and we are again checking if instance is equal to null, then only create the object and we will just return the object. So now we will move to the test.java and we will see this double checking lazy singleton is actually following the singleton approach or singleton behavior or not. So now again in this test class we have created the two objects of this double checking lazy singleton, and we are trying to print the hash code of these two objects. Now we will just run the program. So here if you could see, these two objects are also returning the same hash code. So that means this double checking lazy singleton is also following the singleton approach or the singleton behavior. So this double checking lazy singleton is the best approach or the best practice to create a singleton class, because we can use this particular class in the multi-threaded environment also, and in this case the instance is created at lazily, not at eagerly like in the class loading. So in this video, this much only. If you like the video, please do subscribe to the channel.